Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey. Hi everyone, today we're going to talk about counting techniques, but let's start with the basics first. What if this question is asked to you? If you have 3 blouses and 4 pants to choose for your OOTD, how many choices do you have? This is a practical question or a practical scenario that happens every day, right? But we're going to answer this later. First, let's have some review of the basic concepts that you learn in grade school. Okay, let's start with this question. What is the product of the first 6 counting numbers? Counting number starts with 1. So that means if we have to get the product of the first 6 counting numbers, we have 1 times 2 times 3 times 4 times 5 until 6. Let's use our calculator. So we have 1 times 2 times 3 times 4 times 5 and times 6. And the answer is 720. So we have an answer of 720. Let's have our second question. Did you get the same? Hope you did well, no? You can try it while I'm reading the question. What 3 distinct counting numbers will have a product of 6? So basically in this question, we're going to identify 3 numbers on which the result when you multiply the 3 numbers will be 6. The answer would be 1 times 2 times 3. If you multiply 1 times 2 times 3, the answer would be 6. Why? Because the 3 numbers should be distinct numbers. So let's go to the first thing that we have to learn about factorial notation. Factorial notation of positive integer n. Yan. So before we go directly to this, let's recall first. So you're familiar with notation. Notation is a way of writing numbers, and we've discussed this even you were in lower grade level, right? We discussed about scientific notation when you were in grade 6, and also we discussed about summation notation just in the beginning of our discussion with statistics. So it means that these things are already familiar with you. So when we talk about factorial notation, it is a way of writing numbers. But take note, factorial notation of positive integer, that is represented by n. According to the definition, we can write it as n exclamation point. But we don't read that as exclamation point. In mathematics, we read that as n factorial. It is the what? It is the product of all integers. Okay? It's the product of all integers from 1 to n. So that means it's a product of integer from 1 to n, integers 1 times 2 times 3 times 4 times so on and so forth until n minus 1, until n will actually fit the definition of a factorial notation. But there is this property of multiplication on which even if you rearrange the order of the factors, the answer will still be the same. What is that property? That property is commutative property of multiplication. So that means because of commutative property, we can actually rearrange the factors. Having n factorial is the same as n times n minus 1 times so on and so forth until 4 times 3 times 2 times 1, depending on the value of n, of course. So does that mean if we are going to look for 5 factorial means 5 times 4 times 3 times 2 times 1. Correct. And if we are going to multiply that, let's just put the back button. So we have 1 times 2 times 3 times 4 times 5, and the answer is 120. So that means 5 factorial is equal to 120. Let's have a different perspective in this case. What if you have 4 times 3 times 2 times 1? Can we rewrite this in factorial notation? If we are, then we can actually write it as 4 factorial. So 5 times 4 factorial is equal to 5 factorial, or it's also equal to 120, correct? We can also write 5 factorial in terms of 3 factorial. We can write it as 5 times 4 times 3 factorial. But still, this is equal to 5 factorial, and it's also equal to 120. Last, we can write 5 factorial as 5 times 4 times 3 times 2 factorial, on which if we simplify this, it's still equal to 5 factorial, and it's still equal to 120. That's how wonderful we can play around with integers in factorial notation. But again, we have to rely on the definition when we are confused. Now, We know already the concept of factorial notation. This time, let's learn how to evaluate expressions involving factorial notation. So how do we evaluate? To evaluate expression involving factorial notation, we simply apply the definition and perform the indicated operation. Let's do this manually. Okay, how do we go about it? Let's have our first item. How do we simplify 7 factorial? Just like how we simplified 5 factorial, 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1, which is, we're going to need our calculator here. Yan. So I just click on the left button to go back because I already have 1 until 5 here. I need to multiply times 6 and then times 7. And the result is 5,040. So it's 5,040, teacher. Okay, that's good. Let's continue. I'll put it here because we have another value there. Okay. Erase that part for you. Okay, let's continue. Let's have the second item. Second item is 2 factorial times 3 factorial. Is 2 factorial times 3 factorial equal to 12 factorial, teacher? The answer is no. Why? Remember, the way to evaluate expression is apply the definition, then perform the indicated operation. Let's go back. When we perform the indicated operation, it is like doing what? Doing GEMDAS. Okay. Remember, GEMDAS stands for grouping symbol, exponent, multiplication, and division, which is done from left to right, whatever comes first. When all is done, we do addition and subtraction from left to right. So that means, teacher, 4 factorial is times 3 factorial is not equal to 12 factorial. We have to apply the definition first. Exactly. When we apply the definition, that would be 4 times 3 times 2 times 1 times. That's for the 4 factorial. And for the 3 factorial, times 3 times 2 times 1. You can put it in parentheses if you want to. That will do. Pwede rin yan. Or you can just multiply everything as it is. So if we are going to multiply 4 times 3 times 2 times 3 times 2, that would be 4 times 3 times 2 times 3 times 2 times 1, and the answer is 144. Okay, are you getting this? Let's go to our next example. Our next example is 6 factorial over 4 factorial. Again, to evaluate, we go back to the process, apply the definition, perform the indicated operation. So that means if we are to apply the definition, we have to expand 6 factorial as 6 times 5 times 4 times 3 times 2 times 1. And the denominator will be 4 times 3 times 2 times 1. We can actually cancel the item. Remember, a non-zero number divided by a non-zero number is 1. So that's 1, that's 1, and of course that's 1. So we're left with what? We're left with 6 times 5, which is equivalent to what? Equal to 30. There you go. So our answer is 30. So 6 factorial over 4 factorial is 30. But do you know that there's another way of doing it? How? Remember, between 6 factorial and 4 factorial is lower. That means 6 factorial can be expressed in terms of 4 factorial. And how is that? 6 times 5 times 4 factorial. In that case, we can cancel 4 factorial. So that means, again, we're left with 6 times 5, which is equal to 30 as well. Are you getting that? So next, when we do 8 factorial over 11 factorial, we can actually express which is smaller, 8 factorial or 11 factorial. Exactly. 8 factorial is smaller, so that means we write 8 factorial. We expand 11 factorial, or we write 11 factorial in terms of 8 factorial. So we have 11 times 10 times 9 times 8 factorial. Then we can cancel 8 factorial. Are you getting that? And now we're left with nothing in the numerator, so that's 1 over 11 times 10 times 9. So our answer is 1 over, let's use our calculator, 11 times 10 times 9. And the answer is 990. So 1 over 990 will be our answer. I hope you're getting this. Next, let's move on. How about 3 factorial over 8 factorial? Okay, I'm getting used to this already. So since 2 factorial and 6 factorial are smaller compared to 8 factorial, then we have, sorry, let me erase that and fix it. That's 6 factorial. We can write 3 factorial as 3 times 2 factorial. We can write 8 factorial as 8 times 7 times 6 factorial. In that case, we can cancel 2 factorial and 6 factorial. That will leave us with a numerator of 3 times 8 times 7. So since the denominator is 1, no need to write. So what is 3 times 8 times 7? The answer would be 168. So that means the expression given in number 5 is equal to 168. Okay, let's go to our last example. Our last example is 3 factorial plus 5 factorial. Is 3 factorial plus 5 factorial 8 factorial? That is wrong. Why? This is incorrect. It is because it says in the process that to evaluate expressions involving factorial notation, we simply apply the definition first before performing the operation. So, if we will apply the definition, this will be 3 times 2 times 1 plus 5 times 4 times 3 times 2 times 1. And what's 3 times 2 times 1? That's 6. Plus 5 times 4 times 3 times 2 times 1. We answered this already from earlier, from the previous page, and it is 120. So 6 plus 120, our answer will be 126. So 3 factorial plus 5 factorial is equal to 126. We're going to stop for now, but that's everything about factorial notation. I hope everything is clear.
Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey.